Alright, so in this video we're going to discuss the problem, find the displacement when a person walks 100 meters 25 degrees north of east, then 25 meters 35 degrees north of west, and then 500 meters due east. Now the first thing I want to do is sketch out a tip to trowel drawing, just a rough sketch, not to scale one, to show you the idea of what we're actually doing here, because the component method diagram doesn't help us visualize what's actually going on here. Alright, so we're going to start with the person is going to walk north of east. So if I draw my little diagram here, let's see, 25 degrees isn't too big. And then we draw our little coordinate system again. It's 35 degrees north of west, which is going to put us over here in this quadrant. And then we're going to go 500 kilometers due east, so way over here. So when we are finding the displacement, remember, we want to go from initial position to final position. So that's essentially what the component method does for us. It finds the distance between our initial point and our final point. So by adding the vectors together, we can figure out our displacement. All right, so I'm going to erase this because we don't need it. And I'm going to draw a new diagram. All right, so let's start with our coordinate system. So the first vector is going to be 100 meters above 25 degrees above the positive x-axis. The second vector is going to be 250 meters, 35 degrees above the negative x-axis. So I'm drawing over here in quadrant 2. And then our final vector is going to be 500 meters along the positive x-axis. So we're going to find out that that has no y component to it. All right, so the next step is we need to break these vectors into components. All right, so our first vector here, we're going to have ax and ay. So since the x component is adjacent to the 25, I'm going to use cosine for x. And since the y component is opposite to the 25, I'm going to use sine for the y. So we're going to do ax equals a cosine of theta. So that's going to be 100 meters times the cosine of 25 degrees. And then ay is going to be a sine of theta. So that's going to be 100 meters times the sine of 25 degrees. And since we're moving up and to the right, that tells me both components are going to be positive. All right, so I'm going to pause to get out my calculator and figure out what that answer is. All right, so you can see we have found the x and y component for vector A. Now we're going to repeat for vector B. So we're going to have bx and by. And once again, the 35 degrees is adjacent to the x component, so we'll use cosine, and opposite to the y component, so we'll use sine for that. So we're going to do bx equals b cosine of theta, and then by equals b sine of theta. All right, so let's see, we have 250 meters times the cosine of 35 degrees, and then 250 meters times the sine of 35 degrees. All right, so I need to pause again and get out my calculator. All right, so we found the x and y component, but we need to check the signs. So it's up and to the left, so that means y is positive and x is negative since it's to the left. All right, and then for our last vector, so vector C, it's entirely along the x-axis. So that means all of its magnitude is going to be in the x direction. So we're going to have 500 meters here, and it's to the right, so it's positive. And none of it is going to be in the y direction, so that's going to be 0. All right, so our next step here is we're going to add all of our x terms together. So we're going to go 90.6 meters plus a negative 205 meters plus 500 meters. All right, and I'll pull my calculator out in a second. And then our y, we're going to add our y calculations together. So 42.3 meters plus 143 meters plus 0 meters. All right, so let me pause and pull out my calculator. All right, so we have found our x and y component of our answer. Now I'm going to draw a new little diagram here. All right, so I always start with my x. So Rx is to the right since it's positive. And since Ry is positive, we're going to draw it up. That means we're looking at this angle here. All right, so to find the magnitude, we're going to use Pythagorean's theorem. So 386 meters squared plus the 185 meters squared. Then take the square root. So 386 squared plus 185 squared. Take the square root. And we get 428. And then to find the direction, we're going to use inverse tangent of Ry over Rx. So I'm going to take the inverse tangent of 185 meters divided by 386 meters. So inverse tangent, 185 divided by 386, and that gives us 25.6 degrees. And that is going to be above the positive x-axis.